我们上今天早上刚吃了没有啊。要用的数据处理完，今天两天的测试。
If there is some
All right. Let's start. So today we'll start off with the new topic, which is basically interactability, and just a quick announcement before we get there. So, as you all know, homework 5 is due this Monday. So, and homework 6 will be out tomorrow, and it will be due about 14 days from now. Okay, so it will be due the last week of class. And remember, this is optional. Because I'll take the best 5 out of 6. That's 6. And so the project Midway report, almost all of you have submitted it, but maybe a couple of groups that are left. So if you haven't submitted it, please do so soon. And I've started going through them, but only finished like 5, 6 so far. So I will do that today and tomorrow. That's my goal. Okay, so I will. So you will get some feedback about your project Midway report by tomorrow. Okay. So often it will be short. I mean, I've noticed that most of you are doing a decent job. So I'll just say that, okay, maybe you're going to specify a bit more about this or be more concrete or something like this. So, all right. So that's about your project work. So, okay. So the topic for today and also for one of the class next week is we'd like to understand the limits of efficient computation. Okay, so far we've been trying to come up with algorithms that are as good as possible, and now we ask the question: are there limits to how well or how quickly we can solve a particular problem? So that's the goal. So the kind of questions we would like to answer. Okay, so these are not all things that we will consider this class next, but these are kind of the motivating questions. Okay, like you could ask, for instance, can you sort a bunch of n numbers in time better than n log n? Okay, so it's a natural question to ask. Or you could say, can you find flows in time O of m plus n? Okay, so we can solve where n is the number of edges, n is number of vertices. Right? So the usual. So the algorithm we saw for flow was considerably slower than this. Okay. So we didn't even, in fact, we didn't even exactly compute its running time. But if you trust me, it was considerably slower than this. Okay, so it was something like n cubed. Okay, so right, so you can ask these kind of questions, right? Or you could also ask, is there some polynomial time algorithm for this problem we saw a couple of classes ago, where we did randomized rounding and we found that this was a 63% approximation, right? So you could ask, is there any polynomial time algorithm that does, let's say, a 90% approximation? So these are the kind of questions we'd like to answer. Okay, so actually the first two are a little specialized, as I'll now discuss. But what do you guys think? So first two seem somewhat easier, at least in spirit, right? So what do you have you guys seen lower bounds of this kind before? Okay, so what kind have you seen? Specific for very specific problems. Sometimes it's easy to come up with low bounds if you assume certain models. Okay, so I'm just curious as to, have you guys seen low bounds like this before? Of what?
I think I've seen the second one. There's like a non-comparative version of sorting that leads to, I believe it's ON time.
Well, I was asking about the lower bound, right? So you are saying that you actually saw an algorithm which refutes. I mean, it says the answer is yes. So you're saying that there are some cases where you can do better. So you would have seen what is called radix sort and things like this. But here also it depends on the number of bits and so on. Okay, so you, but it turns out that there are models of computation in which you cannot do better. Okay. So have you guys, any of you seen Nova? Oh, interesting. Okay, so maybe I will put a link to this because that's not our goal today. But I will put a link to a write-up that shows this. But anyway, so one thing I would like to say is this notion of the importance of a model. Okay, so what do we mean by a lower bound? Right? Like we are saying, can we sort n numbers in time better than n log n? So what kind of operations are we allowed on these n numbers? How are they given to us and so on? Right? So that's and that turns out to be an important thing. So this is the term I was referring to. Something that some of you have seen it, so I will just state the theorem anyway. Okay, so if the numbers, so suppose we are given some array. So if the only operations, then the only operations comparisons between AI and no, this is what most sorting algorithms do, right? You just compare, you give two indices INT and you